And so today we shall be considering elements, compound, and mixtures. To begin with, let's start with elements. This is one of the elementary study in chemistry. And that's because we cannot talk about chemistry without mentioning elements. What then is elements? An element is a substance which cannot be split into simpler units by an ordinary chemical process. You see, it's important as a chemist or a chemistry student to know what element is, the various elements we have. It's expected to know at least the first 20 or 30 elements, which is the hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. That's for the first 20. If we mention the next 10 to make it 30, we're talking about the scandium, the titanium, the vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Now, all of this makes up the first 30 elements. The first one I mentioned was the first 20 before adding the extra 10. Now, it's important to understand that if you take hydrogen as an element, you can't split it into any simpler unit by any chemical process. So it's just there, hydrogen. If you split it smaller, you still get hydrogen. You can't break it to change to something else again. That's what we are trying to say. That an element is a substance that cannot be split into simpler units by an ordinary chemical process. And so, like I said earlier, they are the building units of all other substance. Every substance you have constitutes of elements, various elements. Now, there are over 118 known elements. It's almost difficult to have all of the 118, though not impossible. But at least it's expected to know about the 20 or the first 30 elements. Now, about 90 of them are naturally occurring. We find them in nature, while the remaining are artificially prepared in the laboratory. Now, these elements can be grouped into three. We have the metals, the non-metals, and the metalloids. As we proceed, we see how we classify these elements. How do we classify the ones that are metals as metals? Or do we just wake up to realize that they are metals? Absolutely not. There are different characteristics an element should possess that should make it a metal. And so what are the metals now? The lithium, the sodium, the magnesium, aluminium, potassium, calcium, etc. There are so many metals actually. And the metals are more than the non-metals. We also have the non-metals, such as hydrogen, carbon, nitrogen, oxygen, fluorine, chlorine, etc. And so this is just a few of them. And then we have the metalloid. This metalloid has properties that lies between the metals and the non-metals. And the metalloids are the boron, silicon, germanium, etc. And so that's that about the elements. Let's come to compound now. What then is compound? You see, compounds are formed when you combine two or more elements chemically. That is absolutely what a compound is. So compounds are formed as a result of chemical change. You can say as a result of chemical reaction. When we say chemical change, we are referring to chemical reaction. Now, examples of compound are water, carbon dioxide, common salt, washing soda, etc. There are so many numerous compounds that we cannot sit to or stand to itemize every compound we have actually. The list is endless. You are bound to forget some of them. So, well, that's compound. And each of the compound, you can see the constituent elements. You can see in water, it's made of hydrogen and oxygen. In carbon dioxide, carbon and oxygen. In common salt, sodium and chlorine. In washing soda, sodium, carbon, oxygen, hydrogen, on and on. So elements are what makes up the compounds. So below are some compounds and their component elements. The very first is water. Water is H2O. The component elements are hydrogen and oxygen. Hydrogen and oxygen. Then we have sand. Sand, the chemical formula is silicon oxide, SiO2, and it's made up of silicon and oxygen. Limestone, calcium, carbon, and oxygen. And this is it. This is calcium, this is carbon, and this is oxygen. So aside from limestone, we equally have common salts. That's our normal salts. Sodium chloride. So the component elements are sodium and chlorine. We have sugar. So, and the sugar we're talking about is sucrose. And its constant element is carbon, hydrogen, and oxygen. You can see that here. We also have ethanol. And ethanol, this is the formula. Carbon, hydrogen, and oxygen are the constituent elements. We also have washing soda. That's sodium, carbon, oxygen, and hydrogen, and the constituent element. That's the formula. Na2CO3 with 10 molecules of water. We also have hard soap. Sodium, carbon, hydrogen, and oxygen. This is the formula. And lastly, the caustic soda. Caustic soda is sodium hydroxide. Contains sodium, oxygen, and hydrogen. One striking difference is that compounds are made up of formulas, but mixtures don't have formulas. Mixtures. A mixture contains two or more constituents which can be separated by physical methods. The constituents of mixtures are not chemically combined together, and hence they retain their individual chemical properties. Every constituent of that mixture retain their properties, unlike we have in compounds. Now, it's important to know that a mixture cannot be represented by any chemical formula. And here we look at some mixtures and their constituents. One good example of mixture is air, and it contains oxygen, carbon dioxide, nitrogen, noble gas, dust particles, and, well, not written here, but moisture too. Again, soil contains sand, clay, humus, water, air, mineral salts. And for urine, urine is simply made up of urea, water, mineral salts. Palm wine is made up of water, sugar, alcohol, mineral salts, vitamins, yeast, proteins, and fats. Seawater contains water, mineral salts, bacteria, remains of organic matter. For milk, it's made up of water, sugar, fat, proteins, mineral salts, vitamins. Blood contains water, protein, fat, oil, sugar, mineral salts, vitamins, hormones, enzymes, blood cells, and hemoglobin. Crude oil contains petrol, heavy oil, gas oil, kerosene, naphtha, bitumen, gas, etc. Brass, constituent of copper and zinc, actually. Copper and zinc. So, very, very important to note that, you see, every constituent of air retains its individual property. The oxygen in air remains oxygen. It doesn't change, unlike we have in compound. For instance, let me bring your mind back, sodium chloride. You see, when you have your sodium chloride, which is your common salt, the sodium there doesn't retain its property any longer. It's a different compound entirely. I explained that when we did compound. But in air, oxygen is retaining its individual property, carbon dioxide is retaining its individual property, nitrogen is retaining its individual property. They don't change, and you can see their effect in nature. Like for we man now, we breathe in oxygen, and so we don't breathe in carbon dioxide. So what we breathe in air is oxygen. Plants make use of carbon dioxide for their photosynthesis. They don't make use of oxygen for their photosynthesis. So those individual gases that make up air can be used individually, and you can separate the constituents of air. Actually, that's what I'm trying to say. So every component of mixture, as we have in blood now, you can separate water and every single component of blood. Actually, that's what we're trying to say. So unlike compound, you can't actually do that. So these are few mixtures we have here, and there are a lot more of them actually. Differences between compounds and mixtures. 1. Mixtures can be homogeneous or heterogeneous. For example, a mixture of sand and water now, that's a mixture. If you bring sand and combine it with water, that's a mixture. And it's homogeneous because sand is solid and water is liquid. But a compound is homogeneous. They are in the same phase. So next is that concept of mixtures are not chemically combined. And we said that earlier. But the concept of compound are chemically combined. Again, that the concept of mixtures are added in any ratio by mass. But for a compound, the concept of compound are in a fixed ratio. 1:2, there's a fixed ratio by mass to which you combine the constituent of a compound. But that doesn't happen for mixture. Again, is that the parts of mixture are the sum of their individual parts of its constituents. But the properties of a compound differ from those of its constituent elements. I've given an example of sodium and chlorine, which have different properties from sodium chloride. So that's that about that.